This is Mrs. Cribb, and I'm going to go over the most common errors made on the quiz for Chapter 9A. What I did already is I pulled up a periodic chart and attached it, and I also wrote down the pathway between mass and moles and atoms, or molecules or particles. Particles is what is the general term that goes here, but those particles refer to atoms or molecules or things that you're counting. When you go from mass to moles, you need to use the molar mass. And so an example of a molar mass would be the molar mass of, let's say, water. All right, to figure out the molar mass of water, I have to add up the atoms, and so I list the atoms, hydrogen and oxygen, and there are 2 hydrogens, 1 oxygen. I multiply it by the molar mass of water, of hydrogen first, and there's hydrogen, and I look, and it's 1.008, and I want you to round to 2 decimal places. So that means it's going to have to stop at the 100th place. So I look at the 8, it causes it to round up to 0.01 grams in every mole. This is the molar mass of hydrogen. So 1.01 grams per mole. And the molar mass of oxygen, it says 15.998. And I round that to the hundredths place. So it's 16.00. Because the 8 causes the 9 to round up to a 10. That causes this 9 to round up to a 10, which causes the 5 to round up to a 6. So it's 16 grams per mole. That's the molar mass of just oxygen, 1 oxygen, or 6.022 times 10 to the 23rd oxygen atoms. It's 16.00 grams per mole. All right, then you multiply by 2 to get 2.02 and 16.00. Add that up, 18.02 grams per mole. And that's the molar mass of, right here, this is the molar mass of water. Okay, and it's one of the ways that you can write the conversion factor. You would either write 18.02 grams per mole or 1 mole over 18.02. But that's a molar mass example. Now, I want you to notice something. Mass is in grams. Molar mass is in grams per mole. Okay? Now, to go from moles to atoms, you need Avogadro's number. And Avogadro's number is 6.022 times 10 to the 23rd. Then that's going to be atoms or molecules or particles or anything like that. Okay? So the conversion factor using Avogadro's number, and this NA is the abbreviation. It is not the number. It's just, it stands for what the number actually is. So 6.022 times 10 to the 23rd, it could be that many atoms in 1 mole. Or you could write the other conversion factor, 1 mole over 6.022 times 10 to the 23rd atoms. Now, instead of atoms, I could also have molecules, or in general, or particles in general. Now, what you will never have is grams, because grams is the mass unit. Okay, you can't have 6.022 times, you would not say 6.022 times 10 to the 23rd grams in 1 mole. That's wrong. This happened a good bit on this quiz. Okay, that's wrong. Grams is not the unit for per mole. Now, if you happen to have something that weighs that many grams for the 1 mole of it, that's different, but the grams is not part of that. Let's think about this for a minute, okay? I could say I have 12 eggs in 1 dozen, okay? 12 eggs in 1 dozen. Well, then how much does that weigh? How much do 12 eggs weigh? Okay, I'm not sure, so I'm going to go look that up and see if I can find a number for you. Okay, I looked it up, and 1 egg is about 60 grams. So I have 12 eggs. Well, how would I turn that 12 eggs into figuring how much it weighs? I'd say 12 eggs, and there are 60 grams in every 1 egg. The eggs would cancel, and I'd just do 12 times 60. And so if I do 12 times 60, let's see, 12 times 60, I get 720 grams. 720 grams in 1 egg. That's how much it would weigh. Okay? Now, that's how much it weighs, but I could not say Since 1 dozen things is 12 things, I could not say that 12 grams is 1 dozen, because that doesn't work. 12 grams is not 1 dozen. 720 grams is how much 1 dozen weighs. What if I had a dozen, I don't even know, a dozen people, okay? 12 people. 12 people is a dozen people. But 12 people don't weigh 720 grams. 12 people weigh a lot more than that. So you need to be very careful and not get the mass confused with how many that you're dealing with. Okay, we're going to move forward now. I'm going to erase all this. And what I've done is I've gone and I've basically taken the questions from the quiz, changed the numbers and the molecule or the atom, and written down everything else exactly as it was written on the quiz. And I'm going to do several questions like that and work them out for you. So how many moles are in, I'm going to circle my stuff, 43.87 grams of water. So I always circle what I know. Whenever you're doing something, you always start with what you know. So 43.87 grams. Don't start with anything else. Start with the number that's in the question. Okay, now to go from grams to moles, my moles is my question. Notice how I mark it up. Okay, let's write the pathway again. We go from mass to moles, and from moles to atoms or molecules. In this case, we have molecules. But this one's asking how many moles, and it gave me 43.87 grams. So I need to use the molar mass to go from one side to the other. To go from here to here, I need the molar mass. Well, what do I need the molar mass of? Water. I need the molar mass of water. The thing is asking me about. That molar mass I need is water. Now I calculated the molar mass of water up here already. So I'm not going to go through the process again. It's 18.02 grams per mole. And see, I listed the atoms, I counted the atoms, I multiplied them by their molar masses that I got from the periodic table. Right there and right there. Once I multiplied 2 times 1, I got 2.02. So know that this is the total mass of the hydrogen atoms. 1 times 1, 16.00 is 16, and then I added it. 16, so it's 18.02 grams per mole. Right, so the molar mass of water, in this case, is 18.02 grams per mole. So that's one of the conversion factors. I could have also used 1 mole is 18.02 grams. So either one of these comes from the relationship. The relationship is there are 18.02 grams in 1 mole of, here we're just talking about of water molecules. So you always have to deal with whatever it is you're talking about in the actual problem. So now I'm going to use my bridge notation, and which one of these two causes the grams to cancel? Well, this one does, because the grams is on the bottom, and the question is asking for moles anyway, so I want to not cancel that. So 18.02 grams on the bottom, and now we cancel our units, and this I should have written water. You should always write the molecule 2, and if you're not, you're going to cause yourself to make more problems, more errors. If you're not putting your units in there, you will not be able to do it as correctly. I've noticed when I was grading them, a lot of people didn't put units in, or if they did put units, they didn't make sure they canceled. So when you got to the end, you gave me an answer, but the units would not have made any sense. So now we just have to take 43.87 and divide it by 18.02. Put that number there for you, and I put more significant figures than I needed, because at the end you need to evaluate for sig figs. The significant figures come from the measured value. The measured value comes from inside of your problem. You always start here, okay? And so there are 4 significant figures here, so I need 1, 2, 3, 4 sig figs. That means I got to end in that spot. I look at the next spot, and that's a 5. A 5 or higher causes this to round up. So this is 2.435. 2.435, and what is the unit? The one that didn't cancel is the unit. If your unit's canceled, don't put it there. If it didn't cancel, that's the unit supposed to be there, and that's one reason, one way you know, did you answer the question? The question is for moles. I did end up with moles, so moles of water. That's the correct answer. Now, when I got this relationship, it would be incorrect to start with this relationship, grams per mole, and then use this next one with it, okay? You always start with the number that's inside the question. This right here is a conversion factor based on the molar mass. That's always going to be how you're changing the number that's inside the question. Let's go on to the next one, okay? How many grams are in 8.1? So here's my question. How many grams are in 8.1 moles of iron? All right, so we're going to write this down again. Mass to moles, moles to atoms. In this case, it's going to be atoms because iron is a single atom. It's not a molecule. To go from mass to moles, I need the molar mass of iron. To go from moles to atoms, I would need Avogadro's number. So the question in this case is mass, because grams is mass. Remember, the mass is in grams. This is the question. And we're starting off with moles, 8.1 moles. So we're going to go from here to here. We're going to need the molar mass of just iron. Okay? So we start with what we know. We write down the number that's inside the word problem. We have 8.1 moles of iron. You should always write that first. And now I need the molar mass of iron, right here, to be able to convert it, because it's a one-step process. So I go up to the periodic chart. I got to find iron. Here it is. 55.93. So 55.933. I need to round to 2 decimal places. 55.93 grams in 1 mole. Or the other conversion factor would have been 1 mole weighs 55.93 grams for iron only. This is only for iron, not for anything else. All the numbers for molar mass of atoms come from the periodic chart. So 55.93 grams in 1 mole. And this time I write it in this way because I need the moles to cancel. Numerator, denominator, they cancel. And then I'm going to multiply that and put it in. Multiply it out. Remember, if it's on the top, you multiply. And I get this number. I evaluate for significant figures. This is the measured value. Okay, it comes from there. There are 2 sig figs here. So 1, 2. I have to round to this spot. So I look at the next number. That's a 3. It keeps the 5 down. So when I round it, it becomes 450 grams of iron. The grams didn't cancel, and the iron molecule, or atom rather, didn't cancel. Now this is the right answer. It is not 45. That would not be right, because 45 and 450 are very different. This 5 is in the tens place. So the 5 has to stay in the tens place, okay? In the tens place. The value can't change. If you go from 453 to 45, you've reduced it by dividing it by 10. You need to keep the numbers in their same place value. 400 has to stay at 400. 5 has to stay at 50. The 3 ones disappear. That's where you put the 0 in its place to lower the number of significant figures. So make sure you're careful about that. Okay? I hope you got that one. Let's move on to number 3. How many atoms? All right, I'm going to go ahead and write the pathway again. Mass to moles, moles to atoms. And see, remember, this is atoms or molecules, not grams. Mass is in grams. Okay, you need molar mass here and Avogadro's number there. Okay? How many atoms? Okay, that's my question. Are in this many moles of silver. So we're starting with moles here. We have 0.0364 moles of silver. Well, first of all, I got to figure out what silver is. So what is silver? I really don't need the mass this time, but I want to make sure you're aware. Let's look at it. Here's silver and gold. Silver is AG, gold is AU. You need to get those units, those symbols correct, okay? So the molar mass of silver we don't need, but it is, well, let's see, 107.868. I'm going to write it over here, 107.868 grams per mole, but I need to turn it to 2 sig figs. So 107.87 grams in 1 mole of silver. Silver is Ag. Gold is Au. 196.967 would be 196.97 grams per mole. Okay, back down here. How many atoms are in that many moles of silver? So silver is Ag. So what we're doing is going from moles to atoms. Because I've given the moles, I need to figure out atoms. So 0.0364 moles. You write down what you start with. Then you convert from there. I know that every 1 mole contains, because that's Avogadro's number, that remember 6.022 times 10 to the 23rd in every 1 mole, and this is in this case atoms, or 1 mole is 6.022 times 10 to the 23rd atoms. There's the 2 conversion factors. What is never there? Grams, because grams is only found in mass, not in atom count. Okay? So 6.022 times 10 to the 23rd atoms of silver are in 1 mole of silver. All right, units cancel. And this time I'm going to pull up my calculator so you can watch how I put it in my calculator. All right, let's turn this on. We have 0.0364, and since it's on the top, we're going to multiply it times 6.022, second function right there. Yours may be a different color. The comma is where you have the double E that goes along with that same color, but that stands for the exponent of a 10, and the exponent of this 10 is 23. Enter. So 2.1920 times 10 to the 22. So 2.1920 times 10 to the 22. When you put it in the computer, you could put well, first let's do sig figs. There are, now leading zeros are losers, okay? So you come, it's got, the decimal point is present, so you come from the Pacific. You have 1, 2, 3 sig figs. So I need 1, 2, 3. So this is 2.19 times 10 to the 22 atoms of silver. When you put it in the computer, you would put 2.19 and maybe an X, and then 10 up caret 22. That's how you put that in, okay? And then atoms of silver. And anytime you type it in, I'm going to double check it. Okay, so this is the answer for this one. All right, let's go to the next one. How many grams? All right, I'm going to write the pathway again. And now you notice how I'm writing this pathway over and over? Because it helps you to organize your thoughts. We have atoms this time. So my particles in this case are atoms. Remember, these particles can be atoms, molecules, protons. They cannot be grams. Cannot be grams. Okay? So how many grams? This time they're asking for the grams. So the mass is in grams. And this is what they're asking. How many grams are in this many atoms? 4.01 times 10 to the 18th atoms. Okay? All right, so to go from atoms to mole, we have to go, to get to mass, I can't go straight there. You cannot do, and this happened a good bit. People said something like this, 4.01 times 10 to the 18th atoms, and we wanted grams, and so they said there are 6.022 times 10 to the 23rd grams in 1 mole. And then they gave me a number. Well, there's several things wrong with that. The 6.022 is atoms. And if you did this math, notice that none of these units cancel. Atoms, grams, and moles, nothing cancels. So my final unit would have been atoms times grams divided by moles. And that's not what you want. Okay, so that's not going to be correct. All right, so I'm going to erase this. Let's do this the correct way. We have to go from atoms to moles first using Avogadro's number. Okay, so I do need Avogadro's number, but that's only part of the work. I need to turn it into moles. Avogadro's number. In this case, there's the the thing that we need. I need that 1 mole is in 6.022 times 10 to the 23rd atoms. It's the same one that I have listed right up here. Okay, I chose that one so that my atoms would cancel. All right, so now I know how many how many moles of potassium, K, I have. But the question's asking for grams. To go from moles to mass, I need the molar mass of potassium. So I want moles to cancel, so whatever the mass is, I know I'm going to put the mass on top so the moles cancel. I have to go find the molar mass of potassium. So potassium is up here. There it is. It says 39.089. I want 2 decimal places, so I want to round to there. So it's 39.10 grams in 1 mole. What was the other conversion factor? 1 mole weighs 0.910 grams, and this is only for potassium. Okay, notice every one of these changes, the grams change for every element. Every element has a different molar mass. So 39.10 grams. Let's go back down here to the bottom and put that in. All right, so there are 39.10 grams, and we're talking about potassium down here. I should have put that over here. That was my bad. We're talking about atoms of potassium. It should have been there. Potassium's there. Grams in 1 mole. Okay, now we can cancel it out again. 1 mole cancels with 1 mole. And so my unit that I have left is grams, and grams of potassium. That's the question. I want to know how many grams of potassium. So grams of potassium is the correct unit. Now we just have to do our math. I'm going to show you this one again because I'm going to be using multiple scientific notation numbers. All right, so this time we have 4.01. Again, second function. There's the E right there with the comma. And I put in the exponent of 18. And then I usually hit enter. Because I don't know, it's just my habit. But now we have to divide because it's on the bottom. So we're going to divide by Avogadro's number. Divide by 6.022, second function, EE23. Enter. And now on the top, now the next number is on the top, so I'm going to multiply by the next number. Times 39.10. I could, there, 2.6036 times 10 to the minus 4. This E, it means times 10 to the negative 4. So 2.6036. Let's write that down. 2.6036 times 10 to the minus 4. Okay, the last thing we do is evaluate for sig figs. The significant figures come from this portion of the scientific notation, 4.01. So I need 2.60 times 10 to the minus 4 grams of potassium. Okay, that is the correct significant figure answer. Now we're going to do percent composition. And the percent composition requires you figure out the molar mass. We're going to do it for H2SO4, which is sulfuric acid. The first thing you do is you list the atoms. So I have hydrogen, sulfur, and oxygen. So I listed hydrogen, sulfur, and oxygen. I count the atoms. I have 2 hydrogens, 1 sulfur, and 4 oxygens. Okay? So that's how I counted them. I multiply them by their molar mass. We've already figured out the molar mass of hydrogen, 1.01, and oxygen, 16.00. Leave the 2 decimal places there. But I got to go get sulfur. So go up to the periodic chart. I find sulfur, S. Here it is. And this one it says 32.066. I round to 2 decimal places just to avoid having to deal with so many significant figures. So the 6 causes this 6 to round up. So it's 32.07 for this particular chart, grams and 1 mole for sulfur. Okay? The other way would be 1 mole over 32.07. So 32.07. All right, now I multiply 2 times 1.01 is 2.02. 4 times 16 is 64.00. And 1 times 32.07 is 32.07. This is an important step. These are the parts. You have grams per mole. This is not the percentage. This is the mass, the 2.02 is the mass of the total mass of the hydrogen atoms. 32.07 is the total mass of the sulfur atoms, and 64 is the total mass of the oxygen atoms. Now I add it all together to figure out the total mass of the molecule itself. So I'm going to have to add all those up, and I'll put them down. That will be the molar mass of sulfuric. When I add it together, I get 98.09 grams per mole. This is the whole mass, the molecule mass, or the molar mass is what we call it. This is the whole amount. These are the parts. Now, and notice the unit is grams per mole. Notice there are 2 decimal places. Do not round to 1 decimal place. Now we're going to divide by the whole. Okay, so we're going to divide by the molar mass, which is 09 and grams per mole. Well, when you do that, the grams per mole cancel out, so you have just a number. And you're going to multiply by 100, and you have to multiply by the 100. Okay, so I'm going to do that and put the numbers up for you. Wrote it with more significant figures than we needed, and I really just want, for the percent, I want 2 decimal places for percent, and I was a little more gracious with this. So this would be 2.06%, this would be 32.69%, and this would be 65.25%. The percent is the unit. Now you can double check your math by adding all those together. 2.06 plus 32.69 plus 65.25, and I get 100. So this turns out to be exactly 100%. All of these percentages should add up to 100, because this is percent means per 100. So 2.06 per 100. 32.69 per 100. If you would have forgotten to multiply by 100, you would have gotten a number like, let's see, 0.0259 and 0.32 and 0.65. So you have to remember to multiply by 100. So that's the percent composition. And then the question said to enter the molar mass of the compound first. So you should have entered 98.09 grams per mole, and then the percentages of hydrogen, sulfur, and oxygen in that order. And you'd write 2.06%, 32.69%, and 65.25%. Now, this is not the compound you had to do, but this is the same kind of process. All right, now number 6 is worked similarly to number 1. So I would like you to do this one and enter in. You do this. Okay, it's following it the same way that I did the first one. You might need to write it down carefully, but just think about it. Okay, and then number 7, I changed this one because I want to go through the whole process and use ammonium phosphate. So we go from mass to moles, and moles to, this time we're dealing with a molecule, so I'm going to say molecules instead of atoms. Okay? To do the mass to moles, you need the molar mass. To go from moles to molecules, you need Avogadro's number. Okay, this time it's asking for how many molecules. So there's the question. We have 7,681 grams. That's the mass, 7,681 grams. Remember, mass is in grams. And it's ammonium phosphate. So ammonium is NH4, phosphate is PO4. Phosphate has a -3 charge, and NH4 has a +1 charge. You get those off your oxidation chart. Charge is on the top, swap and drop. So put the monster in the cage and bring down the 3. There's the formula for ammonium phosphate. Okay, so we're going to have, this one's going to be a little bit more involved. We're going to go from mass to moles using the molar mass of ammonium phosphate. So we got to calculate the molar mass. You always start with the number you're given. 7,681 grams of ammonium phosphate. NH4, subscript of 3 outside of it, PO4. It's a pain, but you need to write it out. All right, so the first thing I need is the molar mass of this molecule. All right, I'm going to calculate it down here just for space. So first I list N and H, P, and O. So this is a big one. And then I have to figure out how many. So you list it, you count them. All right, there you have to do when you do this, you have to distribute the 3. So 3 times 1 are 3 hydrogens. 3 times 4, there are 12, 3 nitrogens, 12 hydrogens, 1 phosphorus, and 4 oxygens. Okay, and I did this molecule for that purpose. I wanted to review distributing. Okay, now I need to look up the molar mass of each element. Nitrogen is 14.01, but I'm going to double check it. So let's see. Here's nitrogen. It says 14.007. I'm going to round that to 2 decimal places, so it's 14.01. The 7 causes the 0 to round up, so 14.01 grams per mole. There we go. So there are, that's weird. I wrote G. Let me get rid of that. How many? There are 3 nitrogens. Now the molar mass is 14.01 grams per mole. For hydrogen, it's 1.01 grams per mole. For oxygen, it's 16 grams per mole. And phosphorus, I don't know. So let's go look it up. Let's find phosphorus. Here it is. It's 30.97. You got to be really careful writing it down. I do take in count if you accidentally wrote it wrong. I only take off a small amount. So 30.97 grams per mole. Now we got to multiply them. All right, so I'm going to do that for you and give you the numbers. Down. It's 42.03 grams per mole. This is the total mass of the nitrogen in that molecule. 12 grams is the total mass of the hydrogen, 30.97 the total mass of phosphorus, 64 total mass of the oxygens. Add it all together, you have this. This is the molar mass or the total mass of the molecule. So I can put that up here. I need to get rid of the grams. So the other way to write this would have been 1 mole over 149.12 grams. And so that's what I'm going to do here. 1 mole over 149.12 grams. Okay? So now the units will cancel, grams cancel, grams cancel. If I didn't cancel, I did not have it right. If I wrote it the other direction, if I put that on top and that on bottom, it would not have canceled. I realized I got it wrong. So now I've just gone from mass to moles. I now have the number of moles right there. But I want to go from moles to molecules, and I have to use Avogadro's number this time. This is where Avogadro's number comes into play. And there are 2 ways to write it, but I want to cancel the moles. The moles has to go on the bottom and put the number on top. And we're dealing with molecules, so we have to write molecules. We're not dealing with atoms, and we're never going to deal with grams with this number. The grams comes in the mass over here. All right, now let's cancel out. I'm using too many colors. Moles cancel. And what do I have left? Well, just to do this math, and I have molecules, because molecules did not cancel, of ammonium phosphate. NH4 3PO4. And that's what it asked for. How many molecules are in that many grams? Okay, so I just got to do the math, and I'm going to show you one more time how to do that. All right, so 7,681 divided this time by 149.12. That would have told you the moles, but I'm not going to do anything yet until I get to the end. Multiply it because 6.022 is at the top. 6.022, second function, E with a comma, 23, enter, and I get 3.1018 times 10 to the 25th. 3.1018 times 10 to the 25th. 3.1018 times 10 to the 25th. I evaluate for significant figures. This one has 4 sig figs, so I need 1, 2, 3, 4. So it's 3.102 times 10 to the 25th molecules of ammonium phosphate. All right, the last question was just what's the molar mass of argon, or in the other one, it was a different element. We've been doing this a bunch. This was an easy question. All I want you to do is go up here, find the element. This is argon. It says 39.948. We round that to 2 decimal places, 39.95 grams per mole. So if I ask you the molar mass of any one element, you just get them off the chart. Okay, I hope that helps. I will see you soon.